right, two vertical poles, one 16 foot high and one 24 foot high, stand 30 feet apart on a flat field. All right, let's just draw that. There's your flat field. It's sort of flat. 16 feet, so that's 16, and the other one's what? 24. Oh, yep. Okay, so that's 30 feet. A worker wants to support both poles by running a rope from the ground to the top of each post. If the worker wants to stake both ropes in the ground at the same point, where should the stake be to use the least amount of rope? That's pretty stupid. So, this is the situation. We want a rope to support. It's just like you go and you take a look at power, the telephone poles and all that stuff. They have a cable that comes down. That's what we want to do, but we want to put that at the same point. Now, do we want to minimize or maximize? Minimize. Least amount is going to be a minimum value. So, I'm going to call this A, and I'm going to call this B. Okay? Because I don't know what those guys are. So I want to minimize what? I want to minimize A plus B. Now, that's just a framework for what we're doing here, because we want to get it into one variable. And who has an idea how to do this one? Where should we go from here? You could. I'd go for a different way than that. You could do that. You could do the coordinate system, plug them into a coordinate system, and then use distance formulas. You can do that.
So I labeled the distance between the 16-foot pole and the point as x, and the distance between the point and the 24-foot pole, 30 minus x. And then you find the length of the rope, which is the distance between both of those, I think. I don't know, it makes sense on my paper. I don't know how to explain it, though.
Okay. Well, that's a great start right there. What shape is this? What kind of triangle? It's a right triangle. So, if I know 16 and x, can I figure out what a is in terms of x? Using what theorem? Pythagorean theorem. 16 squared plus x squared should be equal to a squared, right? I'm not Mr. Jamil. What?
I don't get how that one's x and the other one's 30.
Well, the entire distance is 30, as you said. If I just said, all right, one of them is x, I don't know what that one is. How am I going to figure out what this one's going to be? And we do that by saying x plus whatever the second distance is, right here, should be equal to 30, shouldn't it? So I don't know what this, and then you subtract x from both sides. Whatever that second distance is 30 minus x. So that's kind of the mathy way of doing it. Whenever you have two distances, or two lengths, segment addition postulate, the geometry stuff. If you know one of them, you subtract it from the total, and you get the second one. All right, so a squared is 16 squared plus x squared. So a is equal to the square root of, all right, someone help me out, 16 squared? That's what I thought. All right, so I got x, I got that. Now, if we're trying to find b squared is equal to 24 squared plus 30 minus x quantity squared. So b squared is equal to
X squared minus 60x plus 1466.
x squared
Minus 60x plus 1476.
That's a lot. So b is equal to, ignore that, the square root of x squared minus 60x plus 1476. It got just kind of thrown into here. We had a 30 squared from here plus 24 squared is 1476. Alright, so now I have an a and a b. So I'm going to find a plus b, which is the square root of 256 plus x squared, plus the square root of x squared minus 60x plus 1476. I'll move this up a little bit. We want to take the derivative of this, don't we? Alright, so remember, these are all kind of to the 1/2 power, right? Alright, so you'll get 1/2 times 256 plus x squared to the negative 1/2 power times 2x. Chain rule for the inside is 2x. Plus one half times x squared minus 60x plus 1476 to the negative 1/2 times what? 2x minus 60. This is just totally ugly. So 256 plus x squared to the 1/2 is in the denominator. 1/2 times 2x is how much? Just x. Plus, can this be factored?
How'd you get plus x? In the denominator.
It's this stuff.
Oh,
I'll get x minus 30 up top because I get 1/2 times 2x minus 60, so half of 2x is x, half of 60 is 30. And then I'll get x squared minus 60x plus 1476 to the 1/2. Well, in this case, they're both raised to the negative 1/2 power, so I have to put them in the denominator, and they're just raised to the 1/2 power. And then, yep, we got to set this equal to 0. So this is the derivative AB with respect to x. Set it equal to 0.
Subtract one of them to put it on the other side.
Yeah. And then cross multiply. No, we got to get a number for x. We must. All right, let's. Yeah, we're running out of room here, so. All right, I'll just rewrite negative x over 256 minus plus x squared to the 1/2 power is equal to x minus 30 over x squared minus 60x plus 1476 to the 1/2 power. Well, what if I squared both sides? And we'll cross multiply first. We'll do that. Do a cross product, get negative x times x squared minus 60x plus 1476 to the 1/2 is equal to x minus 30 times 256 minus plus x squared to the 1/2. Alright, I don't like the half powers. So what do I have to multiply by 1/2 to get the 1? Square. So I'm going to square both sides. So I'm going to square this, and then I'm going to square this. And I can move that up a little bit. By squaring that, I'll get rid of the square roots. And since it's multiplication, I don't have to worry about any crazy foiling like that or anything. I'm going to get, I'll put x squared, negative x times negative x is x squared, times the quantity of x squared minus 60x plus 1476, because 1/2 times 2 is 1. Now, I'm going to get this squared, x minus 30 quantity squared, times the quantity of 256 plus x squared. This is just nasty algebra going on right now. This is just, they're just being mean on this one. Now what do we do? Just keep simplifying, right? When you solve for x, that's when you know how to stop. Alright, so this guy right here, thankfully the left-hand side is going to be nice and easy to do. X to the 4th minus 60x cubed plus 1476 x squared. Now, I got a little bit of extra room up here. So I'm going to go over here. I know I'm going to get x squared minus 60x plus 900, which was the x minus 30 quantity squared, times 256 plus x squared. Of course. Why not? Just make it nasty. Multiply through by 256. 256 x squared. I just really don't want to do this one anymore. Now, is there... Alright, we're running into this huge buzzsaw, this algebraic buzzsaw right now, right? Now, what are we looking for in this case? Well, we're looking for zeros, aren't we? So why don't I just do this? Why don't I just say enough of that up there? And since these numbers are so huge, this is obviously a calculator problem anyway. If I subtracted this stuff from this side, I'll get 0 is equal to x to the fourth minus 60x cubed plus 1476x squared. And I'm just going to subtract this entire bunch of garbage right here minus the x minus 30 quantity squared and the 256 plus x squared. And I don't want to do that anymore. I'm going to graph it. If I want to find zeros, let's just graph it. The highest power is to the fourth power. And it looks like that'll subtract itself out, so we're going to get something to the third power. Because if you look here, you're going to get x squared, and then you're going to get an x squared times an x squared, which would be an x to the fourth. Then you got to subtract it, so it's going to be x to the fourth minus x to the fourth. Because they were equal to each other to start with. So I took the one that was easiest to use here, and then I just subtracted it. I subtracted this guy from both sides. We found out now that that one probably is easier to use. But you don't know it right off the bat. Sometimes you fight through the algebra and then you find out the algebra is too much. So we tried the algebraic way of trying to figure this out. We ran into, it just got worse and worse and worse. So if we want to, we can go back to that original equation right here and plug this in. And I'm going to plug in the 0. I'm going to go 0, because that gives us one line. And then I'm going to plug in the fraction x over the quantity 256 plus x squared to the 1/2 plus another fraction x minus 30 over x squared minus 60x plus 1476 to the 1/2. And I get some craziness that looks like this. That doesn't help me, so I'm going to go to the window zoom, and I'm going to go zoom fit, which is A. And that's still not helping me. So I'm going to zoom out. Where does it look like there might be a 0? Now, Now, taking a look at this graph, does it look like over here that it's kind of just, that would be like a horizontal asymptote type of thing over there? That end behavior, we're getting a nice little, it's an S graph. And how many critical values are there? Well, there's only one, which is nice, so I can just pick that graph. And be done with his nightmare. And out of all that pain, X is 12. Out of all of that pain, X is 12. And there's only 1 0 on this whole thing. So, here, there's a method for why I wanted to show you the algebra. Because, one, you got to see the algebra. You want to see that stuff work. And once you run up against the buzzsaw, like we did here, we say, okay, well, maybe that's not exactly what we need to do in this case. I don't want you to always just rely on a calculator and just throw it into a calculator and be done with it. Because that, if you just rely on the calculator, it's, when you don't have the calculator, you can't do anything. So I want you to attack a lot of these first algebraically.
Would it be okay if you did all the algebra? Because that's what I did. I didn't
Absolutely.
Okay.
Absolutely.
The work got really messy, though.
I'm sure it did. I'm sure it did. I'm sure it took probably about a half an hour.
Oh, yeah, I did.
When I did it with algebra, I got 12, but I also got negative 60. So do I just know that the algebra number?
Well, is negative 60 ever going to be...
It has to be within the domain. It's not as
Okay, so I just kind of scratched that.
Right, yeah, you just kind of scratch that. Now, we figured out through this whole thing that we got x equals 12. And now, when we go back to the picture, does 12 make sense?
Yes.
Would negative 60 make sense? No. Because it has to be somewhere between 0 and 30. So x has to be somewhere between 0 and 30. So that idea of thinking in terms of the coordinate plane is a good one because that gives us what the domain of x can be. It can be as small as 0, even though that probably wouldn't make any sense, and be as big as 30, even though that probably wouldn't make any sense either. So x is going to be between 0 and 30. The only number that popped up that was between 0 and 30 was 12. So I'm going to say 12 is our answer. So I would say x equals 12. So this guy's 12. This guy would be 18. And where should it be placed? You would say 12 feet from the 16-foot pole and 18 feet from that pole. If we wanted to minimize this, what would we have to do? If we wanted to show evidence that is, all right, we'll burn that into your brain really quick. But if we wanted to show the evidence, and I know we put that 12 in there, and we do a sign test. If I put a 12 in here, I should get, that's always going to be positive, isn't it? And that's going to be negative. So that's 12 and that's 18. I'll give you a hint. It's probably going to be negative. If I chose like 0. If I chose 0 as my test point, that would be 0 minus 30 over something. And then if I chose 13, I'll give you another spoiler. It's going to be positive. But we would go into here and we would plot those two numbers. It ends up working. It's not fun. And some of these problems, the algebra is, like I said, is a monster. So if you wanted that full evidence, this would be, or the algebraic way of figuring out the evidence, use your first derivative test. But we ended up using the calculator to deal with that too.